less than 1.6, determining limits using algebraic manipulation. One thing, and we talked about it before, this is a quadratic. You got to know a lot of, remember pre-calculus, a quadratic function is continuous everywhere. So if it's continuous everywhere on all the reals, then you could just plug it in to find the limit. So plug in x is a -1 into each. So that would be -1 squared plus 2 times -1 minus 4. So -1 squared. If you don't do any algebraic, like not writing it correctly, then you might get it wrong. So what's -1 squared? Anybody? What's -1 squared? +1. So see, it goes back to order operation, PEMDAS, and not knowing how to plug in numbers correctly. If you're plugging it in here, you better use parentheses. That's why this is going to become +1. So +1, 2 times the -1 is -2 minus 4. So what is the answer to that? Say it if you know it. What's the answer to that? The whole thing. What's 1 minus 2 minus 4? Mayra, what's the answer to that? -5. So yeah, -5. I think it is correct. The limit is -5. There. Moving on. Should be pretty straightforward. Pretty easy. If you know, the order operations, you know your negatives and positives. This is pretty straightforward. This is another quadratic equation. It is continuous everywhere, so you can just plug it in. Just plug it in. What you got on this one, Adam?
Okay.
Just plug it in, work it all out. Do order operations, positive, negatives. Zero is correct. I hope it's correct. Yes, it is correct. So yeah, this is whatever. The limit as x approaches 2 of 7. So what's the limit? Anybody? What's the limit? 7, because it's just a horizontal line, no? So it just be, if it's a constant, it'll just be 7. Lorena, what's the limit for number 4? Huh? 1,000. 1,000 is just a constant. Is that 1,000? Okay. So moving on. 1, 2, 3, 4. Number 5. Okay. So now, factor and cancel. It says to factor and cancel. That would be the algebra method. But first of all, if we do plug in. All right, let me go step by step on this. So there was the limit law of this thing where you can just go ahead and distribute that limit for the top. So the limit as x approaches 0 of 4x squared minus 5x over the limit as x approaches 0 of x. So this limit as x approaches 0 of the top is 0, and then the limit at the bottom is 0. So we're getting a 0 over 0 that is called indeterminate form. So we got to do more work. So that's what's happening here. All right. So what we're going to do is that we're going to do algebra. to get around that problem of 0 over 0. So if you remember factoring a GCF on top, so what is the GCF for this? What's the greatest common factor for this top one? What can I factor out? X. Again, look, this is algebra. This is just algebra. Factor out the x. X. If you factor out the x, then you're left off with what? 4x minus 5 over x. What can we do here now? Cancel what? X and x, cancel this x. Now, then we have limit as x approaches 0 of this 4x minus 5. And now we can do this direct substitution. And the answer is what? If you just plug it in now for this, what do we get now? Anybody, what do we get? When we plug in 0, what's 4 times 0 minus 5? What's 4 times 0 minus 5? What's going on here? Negative 5. What's going on here? Well, what's 4 times 0 minus 5? It's negative 5, isn't it? So what we do is we plug in 5, we plug it into the top and the bottom. We do get a 0 over 0 indeterminate form. So that's the reason why we did the second part of the homework in knowing how to factor out quadratics here. So I'm not even going to do the x method here. I think we can just go directly to these numbers. So what are the numbers? What are the numbers? Rosalind, what are the numbers? Sayuri, what are the numbers? Okay, 1 and 5 or 5 and 1. And are they both what? They're both negative? I hope everybody agrees and you know that that is correct. And what can we do now? Cancel the x minus 5 and the x minus 5. So now we got the limit as x approaches 5 of x minus 1. And now we can do this substitution. And the answer is what? Come on, the answer is what? 4? So the answer is 4. So there's that. Okay. Let's go to number 7. A little more involved here. You notice that the bottom of this problem number 7 of the fraction is backwards. So we usually have x minus 5, like that would be a factor. But this one has 5 minus x. So how do you fix this 5 minus x? You want to have it where x is first. Well, basically, what you do is you factor out the negative. This is what I'm saying. Factor out the negative, and then that would make this x, put it in the front. So negative 1 times x is negative x. And negative 1 times negative 5 is a positive 5. So 5 minus x is this right here. All right. And when we notice here that this quadratic has a number not 1 here, I want to use my x method here. I do want to use my x method because I don't want to think too much. So what goes at the bottom of the x? For my method, what goes at the bottom of the x? Negative 17. What goes on top? 70. 70. And what are the two numbers multiplied to 70 add up to negative 17? 10 and 7. So this is going to be 10 and 7. Both of them are negative. And then what do we do? What do we do? Divide my answers by what? By 2. Divide my answers by 2. So negative 10 divided by 2 is negative 5. So this is negative 5. This one we cannot do anything else. We leave it alone. So this is going to be the limit as x approaches 5. The limit as x approaches 5 of this negative 1 x minus 5 at the bottom. And then this is going to be x minus 5. And this is going to be bottom to the front, 2x minus 7. And what do we do now? Cancel out the x minus 5 and the x minus 5. So now we can continue on with limit as x approaches 5 of negative, of 2x minus 7 over negative 1. And if you plug it in, we will get what? What's the answer? Is it, what is it? Is it a negative 3? It's negative 3, isn't it? 2 times 5 is 10, 10 minus 7 is 3, 3 divided by negative 1 is negative 3. Negative 3. Yep. Yeah. Let's move on. Let's continue on. Limit does not exist. Why does the limit does not exist for number 8? If we do plug it in, okay? Always you plug it in and just hope that it is. But if you do plug it in, negative 6 here at the bottom, you're going to get a negative 6 plus 6, that's a 0. And if I plug it in on top, I'm going to get 36 minus 24 plus 3. That's going to be what? 12 plus 15. So I'm getting a 15 over 0. So whenever you don't get a 0 over 0 indeterminate form, this is not going to work. So whenever you do get a 0 over 0, it's called indeterminate, and you're doing limits. But let's do it another way. Why don't we factor it? Let's factor even then. Why? But still, let's factor it. So what are the numbers if we do? Come on, what are the numbers? Isn't it 3 and 1? Yes? So can we cancel anything out? Can we cancel anything out from the top and the bottom? We can't get away from this problem of having a whatever it was. So whenever you don't get a 0 over 0, you got a problem. So whenever you get some other number other than a 0 on top, I guess like a 7 over 0 or something like that, and it's a limit, that's going to be a does not exist. So the limit does not exist. So even then, nothing cancels out, and you can't get around that problem. You're going to get a does not exist. The limit does not exist. Um, so you want the top and the bottom to cancel out. If you do plug it in at the bottom, you're gonna get a 1 minus 1 is 0. So you are getting a 0 at the bottom. You plug it in on the top, is not gonna be 0. So you're getting some number other than 0 on top with a 0 at the bottom. That's not indeterminate, but let's practice factoring just in case maybe we can cancel it out, but I already going to tell you it's not going to work. Anyways, but let's just do it. What are the numbers for this when you factor? It's going to be some 6 and 5, no? Which one is, so which one is negative? This is negative, this is positive? But nothing cancels out. So we still got this problem, and that's going to be the limit does not exist. This is just too repetitive. I'm even going to skip. All right, no, let's just do it. Let's go. Number 10. Why? Because we need to practice factoring. So if we do plug in x equal to 4, at the bottom I plug in 4, that'd be 16 minus 4, that'd be 12 minus 12 is 0, so I'm getting a 0 at the bottom. We plug it in on top. That'll be 16 plus 12 is some 30. I think we're getting 30 over 0, which is, it's already not gonna work. Maybe we can factor the bottom, x and x. What are the numbers? What are the numbers for the bottom to factor? 4 and 3, 4 and 3, 4 and 3, which is negative? Negative 4? And what can we do on top? GCF, what's the GCF on top? Oh, what the heck? This is going to cancel out? Oh. What can we factor out from top? Well, what's left over? What? Hold on. This cancels, this cancels. But we still got this problem going. We still got this problem. We still got the problem. If you plug in x equal to 4, then you're going to get 4 minus 4 is 0. But at the top, we get 4 over 0, and that's the problem. And no, you cannot do this. There's somebody, oh, cancel x and x. Look, no. This is a set. Remember? You remember? That's a set. So that is going to be does not exist. So there's some things that you have to remember. Absolutely. We did this with the table. Special trig limits. The limit as x approaches 0 of sine x over x. Let's see. Who remembers what's the answer to that? What's the limit as x approaches 0 of sine x over x? What's the limit as x approaches 0 of sine x over x? We did that table. We did a table for it. Or was it x over sine x? No, it was sine x over x. No? You don't remember? The limit as x approaches 0 of sine x over x, and the answer is what? 1. The answer is 1. The answer is 1. You just got to remember that that's going to be a helpful limit to remember. And if you do the limit as x approaches 0 of x over sine x, it's also going to be 1. The limit as x approaches 0 of cosine x minus 1 over x, that is going to be is that 0? That's going to be 0. So the limit as x approaches that is 0 for this one. Yeah, or 0. And the limit as x approaches 0, this one is gonna be 1 minus cosine x, or cosine x minus 1. 1. It's gonna be 1. This one's gonna be 1. What is 0? What the heck? Let me see. 0. That's 1. What's sign of 0? Oh, duh. Yeah, 0. The 0. So but the main one you need to know definitely is this right here. That one is kind of like, it's okay. This one, you got to remember this one. Okay. Let's go to number 11. So the limit as x approaches 0 of sine 3x, supposed to be together, sine 3x over x. Look, right here, this says the limit as x approaches 0 of sine x over x. These are x and this is x. These guys are matching up, x and x. If I can make this match up right here, then I can use this limit. So this right here, 3x represents x. So what must I have here in order to be the same here? 3. But I can't just put a 3 there. What you do at the bottom, you do at the... And now I have sine 3x over 3, but that's the limit as x approaches 0 of sine 3x over 3x. This is 1, so this 1 times 3, the answer is 3. So we're just doing tricks here. So there's that. Look, you need to multiply the top and the bottom by 3 over 3. 3 over 3 is 1. You're not doing anything to it. And then this becomes 3x. And there's an extra 3 at the top. So it's going to be, this is 1. And then 1 times 3 is 3. Number 12. Who thinks? I already told you what to do. Who knows the answer to number 12? What's the answer to number 12? Anybody? What's the answer to 12? It's okay. Just guess. Huh? 1/2 is correct. 1/2 is correct. So you could just factor out the 2. You don't need the 2. So then you could just do 1/2, factor out the 1/2, and do limit as x approaches 0 of sine x over x. And then this is 1 times 1/2. Oh, that's it. That's it. Let's do a little check for understanding, and we are done. But I think that's enough for the video.